All right, everyone, welcome. It's Tuesday again. This is Dr. B, and thank you for everyone that's joining us tonight here. Um, so final exams are coming up, so that's kind of an interesting time of year for teachers and for students. So in the chat, if you could put when is your final exam, what day, or when is your big exam? I'd be really interested in knowing that. And I see Cloudy's here, Isabella, hello, Sylvia, awesome, and Rotex Edits is here. I'm from the U.S. I'm right outside Washington, D.C., Rotex. Rotrex, something like that. All right. So, yeah, final exams. One of the things that is kind of interesting is with the final exams, if you're in university, you're probably up against it pretty soon. Like Cloudy's saying, next Thursday. Yeah, very soon. And if you're in high school, at least in the US, what usually happens is the teachers, they'll give you some big exam right before break. And Cloudy, you mentioned that. It's because they're afraid you're going to forget everything. So that's why they do that. But December 13th, that's soon. Sunday, that's an interesting day for final exams. Thursday the 14th. Wow, Wednesday the 3rd. It's all coming up. So in the US, I don't think we typically have exams on the weekends. So that's kind of interesting. Good morning, Galaxy. It's actually evening here. So to help you out with the final exams, let me jump over. If you look in the chat, you'll see a list of all my best videos and playlists. So that should help you get ready for final exams. So I spent a lot of time putting that together. So if you go to the top of the chat, it's pinned, and I'm going to show you what it looks like on my screen here. 8 tests in 2 weeks. Wow. Yeah, you see, teachers, they kind of think their exam is the only exam in the universe. I mean, it's the only one they grade, right? But meanwhile, you guys have all kinds of exams. Quite stressful. All right. Where is it? Here it is. So this is the playlist that you can get, and you just click on the link in the chat, and it has all of my stuff. And then it has stuff like this reactions for redox reactions guide. It has a really good stoichiometry guide, all kinds of stuff. So that should help you out. All right, neat exam. Yeah, that's tough, Kanchan. Yep, I remember your message there. All right, so I'll mention this several times in the stream since people kind of drop in and out as we do this. But this is a really awesome resource for you here. All right, so 12:11, that's coming up quick. Wow. Okay, so tonight we're going to do like 5 problems, 5 different common problems, and we're going to try to look at the wording for how teachers try to trick you, or exam writers, they try to trick you. So we'll look at that as we go through. Yeah, all right. So let's jump over to the whiteboard here and do it. Ash, I'm not sure if that pin will remain in the chat if you rewatch it, but if you go to this link right here, or if you write this down, breslin.org, members.exam.html, that'll take you right to it. Hey, Loretta's here. All right, LD. Okay, I like that. So we're going to look at a Lewis structure, molecular geometry, electron config, moles, grams, and then just predicting reactions, just to get you ready for all that. And I'd like to point out we have more people in the stream than this is kind of our record here. So welcome everyone for coming in here. So can you draw the Lewis structure for ammonia? Because you will be asked to do something like this. So give that a try. NH3, ammonia. And what they're going to do is ask you stuff like, say, draw the Lewis structure, but then they'll put stuff like indicating all valence electrons, lone pairs, and atoms. And all of that is just drawing a Lewis structure. Our first step is to count the valence electrons. And probably one of the more useful things to realize about the periodic table is group 1 has 1 valence electron, 2 has 2, 3, 4, 5, all the way up to 8, except for helium that has 2. So if you remember this trend, you'll know those valence electrons. So 5, So that's your first step. Find those valence electrons, because then you can write the structure. So let's get this out of here. So we got some room. We draw the skeleton, and for Lewis structures, always put those nitrogens there. Always put those hydrogens on the outside. So hydrogen, since it only gets 2 total electrons to fill its outer shell, that's all you have to do is put the hydrogens on the outside. And I'm kind of running out of room here. All right. After you do that, put a pair of electrons between them, and that's the chemical bond. So if they ever ask you what the chemical bond is, those are the electrons between. 2, 4, 6. We've only used 6. 8. There is our octet for nitrogen. Each hydrogen has 2. That's the Lewis structure. Hey, Sophia, welcome. And Galaxy, good morning, where you're from. Oh, Myanmar. Nice. All right, so I'm going to copy this. We've got our Lewis structure here. And here's the type of exam question. This is modeled on, I think, the NEET exam. So for folks in India, you might be familiar with this type of question. Kind of a little bit longer than it needs to be. So what they're asking us is to look at the 2 Lewis structures here and figure out their shape, their molecular geometries, and they want us to use the valence shell electron pair repulsion theory to do that. So how do you figure out the shape of each one of these molecules? This is actually an ion here because it has the positive charge. I don't know if anybody knows the shapes of these. If you can just look at it, imagine those, each one of these hydrogens is pushing away and spreading out, and down here they push away and spread out, and the lone pair pushes away. Let's look at it in 3 dimensions. That's the best way. ASL, good night. Good night. All right. So this is an app. I think it's in the description of the video. If not, I'll put it there. Let me just put it in here. This is the app I'm using. So ash tetrahedral would be good for the ammonium ion, but not for the NH3, the ammonia. So imagine this is your nitrogen. We have 1, 2 hydrogens, 3 hydrogens, and watch what happens when we put the 4th hydrogen on. Pushes everything down, and that's because we have an electron cloud around each hydrogen atom, so they push each other away. So you end up with this nice tetrahedral. But if you remember what we had before, so now it's trigonal planar, like Annie's saying, this is trigonal pyramidal. And that's because this lone pair pushes everything down, and it pushes a little bit more than atoms would. Yeah, Ioro, I don't do a lot of organic chemistry. I'm working on it, but I'm more of an analytical chemist or more general chemistry teacher. So I'll have to work on more on that. There's a lot of people that want OChem stuff. And so that's the NH3. We end up with this trigonal pyramidal. So it looks like a lot of folks, they got that there. So I think what's interesting is that this question here wants us to know about the valence shell repulsion theory, and that's how we can tell the shapes. I'm not going to go into hybridization. That would take a little bit longer than we have here. Typically, I hear it trigonal, not triangular, so I would go with that. That's the more accepted, at least in the US, as the name for that. Hey, Wesley, good to see you here. All right. So one of the things I want to talk about just briefly is you're getting ready for your final exams. What a lot of students will do is they'll study the stuff that they're already good at, that's kind of easy, and that's because it's more cognitively enjoyable to do things that, where you get it correct. But when you're preparing for a final exam, you have your syllabus or you know what's going to be on the exam, really identify the things that are giving you problems and work on that a little bit more. Prioritize that, because that's where you get your big gains in your scores and your grade, is by figuring out things you're not very good at and emphasizing that in your study. So don't just study the easy stuff, even though it kind of feels like you're doing a good job and it makes you feel better. And one of the best ways to study is to work as many examples, as many problems like are going to be on the test. And that's probably the single best thing you can do to succeed on a chemistry final exam. So let's do another problem that's kind of similar to what you'll see on a test here. And if you're just stopping in the chat, I've pinned this up here. That's the list of all my playlists. So Galaxy, what link are you interested in? I kind of missed that. All right. So here's a pretty common question is, write the electron configuration for the aluminum. Oh, the 3D shape. Yeah, that is still on my clipboard. Yep, there it is. What is the configuration for aluminum and the aluminum ion? And the way they act, they ask, well, something bad just happened. Oh my goodness. Sometimes you hit the wrong button and things just go away. All right, so figure out the electron configuration for a neutral atom of aluminum. And so a lot of people get messed up with this term here, neutral. What do we mean by neutral? And what that means is that it doesn't have a charge. So everything on the periodic table is going to be neutral. So the quick way to answer it, does anybody know what the answer is? Here's atomic number 13 for aluminum. See if you can figure out which one of these is going to be the correct answer. Ash, I would say that it is sp3. So you are correct about that hybridization. All right. Thank you, Lando. All right. Wow, we have 43 people here. That's the most we've ever had. I don't mean to fixate on that, but that YouTube creator type people get fixated on the numbers here. All right. C. Well, so if you're looking at it, 13. So that's the atomic number. That's the number of protons, but because these are neutral, that's also the number of electrons. So whichever one of these has these little numbers here add up to 13, that's going to be the one that's the right answer. I see a lot of D's. That is 2 plus 2 is 4 plus 6, 10, 12, 13. D is the answer. I'm getting some weird latency here on my pen, so we'll, and it has to end in 3p1. I'm glad you brought that up, Sophia, because let's bring this over here. I'm going to tuck it behind here. Something crazy's happening to my computer. So if you know this chart right here, you can figure out all kinds of stuff. So here's aluminum. We know it has 13 of the 13 of those electrons here. So we go 1s1, 1s2. So that's our 1s2. Then we go second energy level, 2s1, 2s2. And something is crazy with my pen, but we'll do our best. 2p1, and you're told that p holds up to 6. 2p1, 2, 3, 4, 5, 6. So that's where that number comes from. It's supposed to be a 6 here, but things are going south. 3s1, 3s2, we've used 12, and then right here, 3p1, that's the highest energy level. So yeah, so you can use this chart. There's videos for you on on that playlist. If you can use this chart to do this, life is going to get a lot easier for electron configurations. And think about it here. Like if you look at this Bohr model, in this first level, there's 2. That's our 1s2. Second energy level, we have 2s1, 2s2, and then we have our 2p6. And that outer energy level, you've got 3s2 and 2p1. And the outer energy level, those are the valence electrons. Yep, 3p1. So what would you do if you wanted to make this the aluminum ion, though? What would I have to do to make this Al3+? If it's 3+, it means it lost 3 negative charges, 3 electrons. So to lose 3 electrons, we just delete this right here. And we do get that noble gas configuration. And it would be 1s2, 2s2, 2p6. So it actually, Annie, it would just be the neon configuration then once we make it Al3+. I think you have Al there. I think that's what you meant to have. So that's correct for Al. Yeah. All right. That's the electron configuration. YouTube's giving me all kinds of warnings that that my computer is not up to speed. Are you guys seeing things all jumpy, or is the quality okay on your end? That's be interesting to know. Cult of Sarin, it loses 3 electrons. So the aluminum loses 3 electrons and it becomes Al3+. And when it loses the 3 electrons, now it has a noble gas configuration. So this is very stable. That's why we do that. Okay, yeah, I see, Annie. Yep, Sophia, that is correct. It lost the 3 there. So all these things are related, and if you can tie these together, if you can tie all these things together in your head, this configuration, the Bohr diagram, and the configuration like this table here, you'll be in good shape. Thank you, Polona. That's just the pen, huh? Well, what's really good is I spent all weekend long and I got the components and I built an awesome new computer. I've just not set it up. So next time we stream, it should be pretty amazing because I built this new computer. It was really hard, but I got it done. So it's almost ready. Some lag. Okay. All right. And I think we have people from all over the world here, so which is kind of amazing in itself. All right. So let's go do a few more. And where are we at? Yeah, we'll do a few more. And if it's too laggy, because it makes me look, someone's going to watch this later and think I can't write like I write like a 3rd grader or something, which I guess is okay. So if you've been with me doing streams, I think we've done like over 30 streams. One of the things that I like to teach my students about moles to grams is you want to be able to do it really quick. So just remember, moles to grams, you multiply by the molar mass. And that really helps, because then if you go from grams to moles, you just divide. So this is a kind of question you might see. It's a little simple, but I think you'd see this in a general chemistry exam. Let me put these over here. See if you can do this one. Thanks, Ash. I appreciate that. That's very nice to say. So here they're asking you 2 moles of water, what's the mass? So moles to grams. So we're going from grams, that's mass, right? So moles to grams, multiply. Whenever I do that in class, my students all groan, but you do remember it by the molar mass. So for H2O, we're going to have 2 hydrogens because it's H2 plus the 1 oxygen. So 2.02 plus 8, that should give us what, 18.02? It's very difficult to write like this. And the unit's really important, grams per mole. Don't forget that. So if you have 2 moles and you multiply by the molar mass, the answer should be 2 times 18, we're going to round it, is 36. So right, Andy, 18 grams would be for 1 mole. There you go. You got it, Andy. I know you know this stuff. Yeah, so it'll just be double. So when you write this out, I'm not going to write it out because my pen's all whacked this evening, but when you write it out, make sure your units cancel. But just for that first approximation, you can almost do this stuff in your head when you have this in your brain. And if you went from moles to something like molecules, you'd multiply by Avogadro's number. If you went from moles to liters for an ideal gas, you'd multiply it by that 22.4 number. So kind of nice to help you go quickly through. Galaxy, you're asking me how to calculate. I think you want to see me write. Okay, 2 moles times the molar mass, 18. I'm just going to call it 18. I'm going to round it. Grams per mole. Okay. The thing is, we have moles on the top and the bottom. They cancel out, and we're left with those grams. So 2 times 18 grams, that's 36 grams. Thank you, Ash. That's probably the easier way to do it. Let's do one more. Let's do one more of these here. And if you're just coming in, this is pinned up in the chat, and it's got all my playlists, and it's very concise. I like things that are concise, very direct. So this will save you time when you're preparing for all of those exams, not just chemistry. This one's going to be a little bit harder. So I think what I'll do is I'll show you the picture here of the reaction. Hey, thanks, Jessica. That's all right. And thank you for being a member. That's really appreciated. So for this one here, what you really have to do is you need to know, first, you have to figure out what the ionic charges are for each of the things. So the Ag, the NO3, and the Na and the Cl. So if you know this, you can do a lot of things. Like here's Na. So Na is positive. Chlorine's over here somewhere. That's going to be negative. And then you just need to memorize that the nitrate ion, the whole thing, is 1 minus. And because of that, we know that the silver is going to be positive. Silver's weird. It's always 1 plus, even though it's a transition metal. So if you match these up, Ag goes with the Cl, you get that AgCl. Na goes with the NO3, and you've got your products. And Kodovsaran, I see you've got that in there as well. And the chat's a little bit slow tonight, too. Let's see what we got. Annie, you're saying it's A. We'll see in a minute. So we know the charges, right? That helps us figure the products out. But now you need to figure out the products. Let's put this over here. And which one's going to be soluble. So which one is going to be a solid? That'd be our precipitate. I'm really fighting with my computer. I'm ready for that new computer. Next Tuesday, we'll have the new computer. It'll be amazing. All right. So because of that, we know that AgCl, so Na, things with Na, they are always going to be soluble. Things with Cl usually are soluble unless it's bonded to these things, and there's silver. So if you know the solubility rules, and there's links in that page I mentioned, you know that the precipitate is AgCl. So this white substance here, that's all the AgCl. So that's how we know the precipitate there, using the solubility rules and the charges. And I have a few things in chat here I want to address. So, yeah, with the significant figures, I'd really been kind of sloppy tonight because my pen's messing with me. But I would I would with multiple choice. It's easy. Usually they don't mess with you too much unless it's a specific multiple choice question. But you want to use whatever's the least number of significant digits in the problem. That's all you should have in your answer. Because basically you're saying that's how accurate my instrument is. So that's how accurate my answer can be. That's the way we kind of think of that. Django, that's a kind of a deep question about the five bonds. One of them's a dative bond or a coordinate covalent bond. And we could talk about that for some time. The thumbnail for the said Chem 101. It might have. Yeah, this is AP, General Chem, most of those. It's all pretty much the same general stuff. That core, I cover the core stuff when I do this. All right. Yeah, anything, Fungi, anything you can memorize. We've talked about cognitive load. We talked about this idea in other streams about how anytime you can memorize things like your polyatomic ions or simple things like that, like moles to grams, you multiply, you lower the pressure on your brain, essentially. It lets you do other stuff and attend to answering the question. So anytime you can memorize those core things, that helps a lot. Molecular orbital theories. That's I am when I was a student, I struggled with that, and I'm probably not the best person to teach that at this point, but maybe I'll brush up and do some MO. It's pretty cool stuff. Okay, I see what you're saying, Annie. Yeah, so that's pretty much what I have here this evening. High ground, if you go to, do I have it anywhere here? If you go to this link here, if you go to the chat, you'll find this link at the top pinned. If you go there, you'll find everything you need. So one of the last things I'd just like to say to everyone is really, as we head into these final exams, it's important to manage your stress, because what happens with stress is it means you don't encode information as well into your brain. So you don't store it as well. It makes it hard to get it back out. And then just memory in general, retrieval is messed up. So try to prioritize what you need to do and then focus on the things where you're struggling, because that's where the most points come from on your exam. Find resources like some of my resources and other folks, but manage the stress, prioritize, and take breaks, take deep breaths in between. That's real important. So I'm going to wrap up now with doing stuff, but I will do some question and answer stuff for folks that want to stick around. And I see Cassandra's got to go. Fourth exam tomorrow. Wow. Well, I wish you the best on that. I remember those days where it's just nonstop. Hey, thanks, Ash. I'm particularly proud of that balancing chemistry, balancing equations video. It's my best video. It's got millions of views. Kind of crazy. So, yeah, well, thank you very much, everyone, for watching. We had the most folks we ever had here on the stream. And if you have questions, I'll stick around for a few minutes and try to direct you to some resources. Yeah, it's Dr. B, and thanks for watching. See you next Tuesday. Yep, XOPAEA. I'm on every Tuesday at 8:30 Eastern Standard Time. This time here, yeah. And Cult of Siren, you've got Vespra. If you search Breslin orbital diagrams, you'll find that. I've got videos on polar, nonpolar. All that stuff's in that playlist that's on the screen right now or in the chat. Did we have up to 63 people? That's like almost double what we've had in the past. See, what I did was I I put a community tab post with a quiz question, and in the answer I put the stream for tonight, so maybe that helped. Intermolecular force and solubility. So Cloudy, if you search Dr. B intermolecular forces, I did a bunch of videos like that, but let me see if I can quickly find that. Let's see if it works. Dr. B. Yeah, see how all of those come up there for the intermolecular forces and make it bigger for different compounds. So if you follow those examples, try to figure it out yourself first and then watch the video. That should get you in a good place. And some of them I talk about solubility, especially like hydrogen bonding and ethanol. Bond polarity. Ash, that's a good question. So bond polarity, I have a video just on polar nonpolar that's pretty good. But if you type, let's see what comes up. It's always fun when you do this and you see your stuff. It's kind of exciting. Polar nonpolar right here. This is a really good video on polar and nonpolar. If you take a look at that, I do not have a lot of stuff on temperature, volume, and pressure yet, but if you go to sometimes the PHET temperature, yeah, if you just type in gas properties PHET, they have a really nice animation and simulation that helps you. And Annie, usually what happens with the ideal gas law, it's that constant R that causes people problems. And when you look at that constant R, it's depending on the units they give you for pressure in the problem. So if it's atmospheres, you use one unit for R, one value for R. If it's kilopascal, you use another. And teachers will usually give you that information on a test. Hey, Jacob. Yeah, I'll be back next Tuesday. So, oh, yours is this Thursday, so that won't help. Make sure, Jacob, if you need some extra stuff, to go over to Breslin.org members/exams, or just it's pinned up there. There's a lot of stuff there, but I think I'm going to have to do videos on gas laws. Lots of folks have asked me. I know Eoro asked me at one point about that, and maybe that's my next big video set. I just did redox reactions, so maybe gas laws is the next big thing for me to do. Not necessarily in a closed container. Yeah, it gets a little more challenging once you're not in a closed container. I'll have to think about that. Oh, you do understand the constants. Well, you're in good shape, Andy, because a lot of people really have a problem with. That's really what stops a lot of folks. I'll think about doing more gas law stuff. Yeah, that's a good question, Ash. I don't have a quick answer for you. Hey, Troy. Yeah, the redox reaction videos, I spent so much time on that. It was insane because there's so many details, and it's really hard to learn for students. So I actually read all the research literature and tried to figure out how to help folks. Ash, I think that's because the 8.31 is for kilopascals, and then the 0.82057 is when you're using atmospheres as your units. So it's really just the units to do that. Shana, you should look at my videos on solubility in that playlist, the thing that's pinned in the chat, and it'll tell you how to use a solubility table or the solubility rules to figure it out. But compounds with sodium are always soluble. Angel's asking me about thermodynamics. That's another thing I've not done a lot with, and I'd like to, because yeah, it's interesting. You know, the idea of lowering energy, driving forces, and entropy, and all that. That's just fascinating. Yeah. Unit 7 and the comprehensive exam next week. Yes, everybody's got their exams coming up. That's just kind of it's a tough time of year. And when I was in college, I noticed this more than in high school, but after exams, people have been so stressed out by their final exams that they'll actually like get a cold because their immune system is depressed. So you got to take care of yourself up to and during final exams because it's a big stress on your system. All right, I think I am going to call it an evening. Maybe I'll work on my new computer so I can have that for next Tuesday. Thank you, everyone, for joining me here this evening. This was a lot of fun, and I will talk to you soon. Take care. And best of luck on your finals for everyone that has them. Oh, Ash, I actually have a good thing to help you with that. Let me look at that real quick. All right, Annie. See you later, Annie, and everybody else that's there. I'm actually just want to give Ash this resource. If you go to MolView, molview.org, and you click on this up here, you can see the surface of molecules, and you can have it show you the dipole and everything on them here. So it shows the surface, and you can say, show me the bond dipoles. Oh, I have to clear it. Bond dipoles, and it'll show you any molecule you search on up there. All right, folks, have a great evening. Good night, Loretta and Cloudy, Annie and Shana.